OmniScan MX2 training program, use of FocalLawWizard. After completion of the part and weld and setup wizards, we're ready to do our beam formation and determine the number of A scans and configuration of the group. Select FocalLaw Start. Our options for the law configuration are sector, linear, and linear at 0. Sector, multi-angle from the same group of elements. Linear, one angle multiplexed across a large element probe. And linear at 0. This is an exception that allows a volumetric corrected C-scan at 0 degrees that has a limitation of one group only in the setup file. Select Sector Scan. The legs we select will be relative to the ray tracing feature. Select 1 and Next. When we selected the material type from the part and weld wizard, we associated two velocities, the longitudinal and shear wave velocity of the material. Select shear wave and Next. The element quantity is relative to the size of the aperture, and the first element position is where the 16 elements start, and it's relative to the beam exit point within the probe. Select Next. Our minimum and maximum angles are determined by our ability to calibrate them, and most combinations are designed in the range of 45 to 70 degrees. With a one angle step resolution will give us 26 total A scans with a focal depth of 50 millimeters. Select Next. Ensure your gate position is going to be over your target. We can change this after the wizard, but if you know your target position, in our example we're going to use a 1/2 inch or 12.7 millimeter target, so our gate position will place the gate over the relative target. Select Next and Generate. At this point, both the part and weld, the setup and FocalLaw wizards have been created, and we have our basic S-scan display. To verify beam parameters after the FocalLaw wizard, we can select Display, AS and C-scan, bring a cursor up, and we'll put a cursor on the UT axis at the position of our indication, and as we move the probe left and right over to calibration, we can see that it's maintaining its same position and depth. It's not moving up or down. It's normal that it changes shape towards the higher angles because of the beam spread, but it's an immediate indication prior to calibration that the parameters of the probe, wedge, material velocity, and beam forming were all correct. If there was a problem with one of those significantly, we would not be able to maintain the constant depth across all of the focal laws.